Again, coming together for our weekly rendezvous just to have little fireside chats around defensive topics. We've got a guest on today, Jim from Deterministic Security. These guys do some really cool stuff around sort of malware analysis, malware sort of sandboxing, and which is obviously a highly relevant topic to those that are in defensive roles. And so, always eager to hear from folks that are kind of at the cutting edge of interesting research on things that can help enable analysts and incident responders to do better work. So, welcome, Jim and Julian from Deterministic. How you guys doing?
Doing pretty good. Yeah, thanks for having us on.
You bet. So spread some love, some wisdom. What's on your mind today, guys?
Yeah. So while Jump's getting logged back in, I'm just kind of kick it off. So to us, one of the things we've been interested in lately is this notion of a programmable sandbox. And we kind of kicked this idea off at Mission Control, which was a really great venue to kind of present that idea. And the thought kind of came about because we're in the sandbox market, so we kind of look at all the other sandboxes and we're trying to figure out what's our niche. And we talked to a lot of people in SOCs and MDR markets, defense contractors, and try to understand what it is that's actually going on and the need for people. And one of the things that we keep hearing over and over a lot is that each different network has its own sort of ecosystem to it. And so, you've got the big companies that give you one size fits all kind of product, but then it doesn't really get applied. It doesn't work that well in an individual ecosystem. And so we thought that was a really interesting observation. And in our sandbox market, which is kind of a subset of the overall thing, we see that as a similar kind of thing. It's like you don't necessarily want a one size fits all kind of sandbox. There's different types of things you want to analyze. There's different types of alerts people are interested in. And so that's kind of how that idea is brewed. We're interested in kind of pushing that forward.
No doubt, no doubt. So, in your experience, I guess, what is the most common problem out there that blue teams are trying to solve when it comes to sandboxing? Like, is it just your conventional malware, just want to be able to toss a sample into a box, detonate it, and get a report? Or are you seeing more sophisticated use cases coming up as teams are maturing and evolving?
Well, I
I
think
would, yeah, go.
the need here basically comes down to, at this point, you have automation everywhere. You've got a lot of endpoint tools everywhere. You've got a lot of network analysis tools everywhere, and they're all highly configurable, and they all take rules and things like that. So I think right now, me and Julian really like to talk a lot about what we call the validation problem, and that's a very broad problem. But in this case, the validation problem, I think the big problem right now, I would say, is like when you get these rules from different threat intelligence sources and from different open source intelligence sources, how do you know if those rules are good or not? How do you know that? I mean, it could be a supply chain attack for all you know. It could be someone, an adversary, putting stuff in there to trigger false alarms to distract you. There's all kinds of things that you need to think about when you're grabbing rules from different places. So we're really interested in helping validate those rules. Having like basically large data sets of malware just ready to go that you can then run rules against. That's kind of the capability we're building towards right now. We're piloting that capability with people. So we're really interested in that problem. Um, looking forward, there's a lot of other interesting things going on right now. And we could talk about like AI and offensive cyber all day long if we wanted to, but that I'm kind of in the wait and see mode on that one right now. But I
Yeah.
think right now the immediate problem is this validation issue is the big problem I see.
I think to add to that a little bit, one thing that we actually see a lot is some of the people we work with, they actually have other sandboxes. And so you're like, well, why would you buy REnigma when you've already got, this other sandbox? And it turns out the problem that people tend to run into with the sandboxes is that you get these alerts, but you don't really understand what they mean. It's like a one sentence tweet on what the sample's doing, but you don't actually understand where that alert came from and like what does that actually mean for this sample. Especially, it depends on your context. Are you using this in incident response? Are you using it as like open intelligence research or whatnot? But really, a lot of times you just want to understand deeper about, okay, what is this sample doing? What can I learn about this to help secure my network? And you just don't get quite enough information.
I like that. And something Jim said really resonates with me. It's so, there's obviously, as you mentioned, there's no shortage of sandboxes, like a lot of, freemium options out there. But one of the things I think that most of these offerings are missing, and I'm curious if you guys can, are able to bridge this gap, is it's great to be able to detonate a malware sample to get a better understanding of the capabilities of the malware. Got it. Like that's kind of the status quo of sandboxing. But I think it's even better to be able to run that through something that is that's also evaluating my production rule set as well, right? So if I've got 4,200 detection rules in production, I'd love to know which of those rules would have triggered based on this malware sample. So I'm not only learning about the malware itself, but I'm learning about coverages and lack of coverages of my detection rule set against this strain of malware. Is this a common feature set in sandboxes these days? I genuinely don't know.
My position on this at this point is there's people that are working on this problem, but it's very much a custom, like you have to really know what you're doing to build this capability up. And, I think there's a lot of room for automation here. Like our plan to address this problem is essentially, we'll go out and download malware for people. You can have your own historical sets that you've already recorded. But then the idea is if you come up with a new idea for a rule or you download a new rule, then you can basically have like a button press where you just automate the checking of that. And that's really what we're basically looking at deploying this year for our clients.
Got it.
At the broader level, though, I think that the problem really comes down to something much deeper, which is, so to get a little bit theoretical for a second, if you think about how a sandbox works, it's really a sampling problem. So you've got like a virtual machine or an emulator running the malware, and then you get a report at the end, and you may get some alerts from that report. But how does that actually come to be? Like, how does that report actually get created? And the answer is there's breakpoints that have to get triggered somehow, either on system calls or API calls, or it's collecting PCAP data, or pausing and dumping memory and doing YARA scans of memory. These are the raw primitives that these sandboxes have. And the problem with that is if you're running a sample, and to run the sample, you basically have to run it at full speed because the malware can, detect if it's being slowed down or whatever. So there's all kinds of, there's this whole cat and mouse game of anti-analysis you have to play. But then once you get it to the point of running, you still have to collect data in a way that doesn't interfere with the execution if you're collecting that data live. So we sort of cheat on this whole process. We get completely around that problem by simply recording everything that happens at full speed with our underlying hypervisor technology that we're built on. And then we can do all the really expensive stuff during replay later. So we can drill down all the way. And what that enables us to do is we essentially get full collection for free. And then instead of having to sample, we can still do the same type of sampling where you're going to collect system calls and API calls and whatever. But then we can go further. And the thing that Julian presented at Mission Control is basically demonstrating an example of that. So we presented the backtracker, which basically in that talk, we were showing going backwards from like packets that were being sent out on the MMIO to the hardware and the emulated hardware for the virtual machine, and then backtracking all the way back to plain text and memory, like a TLS flow. So being able to get to root cause, and that can get you close to like the command and control of the malware. And then you can really start to understand from a semantics perspective, what does this thing actually mean? And then you can then go forward again back to the things that you're sampling and then say, okay, well, if this rule fires, I know that it's firing because of XYZ, and here's the root cause. So that's really what we're building towards with this new type of, like automated reverse engineering plus this rules validation engine and things like that. So it's, the pieces of it are already in place. And as we get more of it going, we're really excited to kind of put that into practice with people.
That's awesome stuff, man. Yeah. I'm curious. One of the things I know that malware has sort of developed and evolved over the years to try to, evade analysis and reverse engineering is a lot of like, VM awareness, right? Understanding if it's in an analysis environment. I'm curious, like, how do you guys, and I'm sure that's another cat and mouse game because it's like, they have one detection technique, you have one, way to get around that, right? But how do you constantly stay ahead of that to, it's almost like Schrodinger's cat, right? Like, if the malware changes its behavior because you are observing it, how do you know you're observing the true behavior?
Well, I'll first off just start off by saying, from a theoretical perspective, we're nerds. We all know about the simulation hypothesis. Um, Ultimately, you want to put the malware in a simulation where it can't know the truth. That's the long-term answer. Um, with REnigma, the way that we tend to set up the VMs, we get a lot of this stuff for free. You in the sandbox environment, you kind of have a choice. You can either put stuff inside of the guest VM in user space, you can put it in the guest VM in the kernel, or you can do it from virtual machine introspection at the hypervisor level. By default, everything that we do is at that VM introspection level, although we do have some VM configurations that let you put stuff inside the sandbox. But if you avoid putting stuff inside the sandbox, then you get a lot of the stuff for free. Like all the debugger checks won't detect anything, and all the, looking at the environment for, Wireshark's on the desktop or whatever. So the malware won't know that stuff. As far as like the other things, there's only really a few different types of things that malware can look for. Certain, like if you're in Windows, certain registry keys, certain instructions, certain system calls, and things like that. So the way that you deal with that problem is ultimately you have to control it, and there's a whole bunch of different options on how to control it. I think that would be probably a follow-up episode. We could go into depth on all the different things there, because like you said, it's a huge cat and mouse game. But the answer is basically, you have to. The answer is, first you have to be able to see it, and then once you can see it, then you have options on how you can address it. Ultimately, though, it is a cat and mouse game. But as long as you're, I like to think about things from like basically what's the most fundamental question you can ask about this particular topic, and then find what I call the invariants, the things that have to be true. And so anti-analysis relies on a few key invariants about detecting what the environment is, timing, things like that. So you just have to control those things to be able to defeat it.
Got it. So you guys know, Liam and Charlie, we're huge fans of REnigma. We've done a lot of work together. We recently published a new extension that enables use you guys. We try to keep Defender Fridays a bit vendor agnostic, though, right? So not to overly promote or pitch you guys specifically. Obviously, anyone that wants to learn more about REnigma, I would strongly encourage you to check out their website, as well as the talk that Charlton just dropped there. But I want to know holistically, right? How can blue teams better operationalize sandbox technology? And let me clarify what I mean by that. I think that historically, as you mentioned, right, you send a sample into a sandbox and a report comes out. But one of the things I don't love about that is that means I've got to do something manually with this report. I've got to, study it, analyze it. To your point earlier, like there's going to be some really vague, obscure things. Like, okay, great, it's using a packer. What does that mean, and why do I care? But more importantly, how do I close the loop to automate the intelligence that comes out of that sandbox, so that I can basically kind of set it and forget it, right? Send high confidence samples into sandbox, have the intelligence extracted automatically and operationalized in sort of a loop. Is this even advisable? Is this possible? What are your thoughts on that?
I'm a big fan of anything to automate and get, the problem with people in the loop is that even though human beings do have the best pattern detector and the most generic capabilities, we're slow. We get tired. We can overlook things. It's really easy to get. I mentioned that, fake alerts, wherever, to get distracted, things like that. So I think automation is important as kind of the foundation, just to be able to assist the user with the things that are easy to make mistakes on. But the problem with automation is it is ultimately limited. And we can talk about automation with traditional algorithms or with all the fancy LLM stuff. But either way, no one solved the autonomous LLM problem yet. And I know that there's all this new stuff coming out this last month, but it's still a big problem to be able to let these things fully run on their own. So I think Julian and I for a long time have used what we call the chess computer analogy, and that the idea is, after like Deep Blue beat Gary Kasparov, obviously the best chess computer could be the best human, but for a while there, until AI really matured more, like when we got in like the 2010s or whatever, with like all the Google what's it, DeepMind stuff or whatever, that like basically the best chess player was like a human plus a chess computer, because the human could then add kind of a wild card aspect to it, where the chess computer on the other side couldn't necessarily predict what's going to happen. So I think I think that combination is still really powerful. So you want automation as the foundation, and you still want the person in there, but you don't want to be going through the report manually and pulling out like line by line. Here's IOC and copying. Like you want to get all that stuff gotten rid of completely because that's so error prone.
No, I love it, and I especially like that you use the chess computer analogy because I was just watching something the other day that used that same analogy when discussing sort of the rise of AI and sort of the impact of it all.
Yeah,
And it's funny because there was absolutely like a threshold that was hit once AI could be taught the game of chess, and then it could be set loose to basically iterate through thousands of games against itself, right? To think of every strategy and every counter strategy and all those things. It reached a point, where a human being will never beat a computer at chess again now, right? It's
yeah,
it's not that it's going to be a tough match. It's impossible. Like it won't happen. And I think that's something that I think a lot of AI skeptics in security maybe don't quite recognize or realize that sure, it's easy to sit back and be skeptical today and
yeah,
point at all the flaws and all the inefficiencies and LLMs and that's not true AI and a lot of that is true. But I think it's foolish to think that we're not going to get to a point where you can create a feedback loop of a model that's training itself constantly that will outpace any human analyst. And I think that's on the short-term horizon. Personally, maybe I'm being
yeah,
overly optimistic, but I think we're closer than a lot of folks would like to admit to automating a human out of it. Because to your point, right, where humans excel, like and this will go right back into a malware reverse sort of topic. Where humans excel is we're generally intelligent, right? So
yeah,
I can think of new and interesting things. Just I become inspired, right, to go down a different rabbit hole. Whereas a very finite model is only going to do the things that it knows how to do. But
absolutely.
but to your point, we're slow. We are we're prone to make mistakes. We're prone to misinterpret things, and so I do think that the end goal is to automate as much of that as possible. But I would agree with you.
Yeah.
I don't think we're there yet. But
Well, I think the larger like effort that me and Julian are really trying to do, and we don't really do a whole lot of AI stuff directly. We dabble a little bit for different use cases, but um, really what we're trying to do is automate with traditional algorithms as much as possible on the reverse engineering and malware analysis side of the house. But then that the goal there is then to free up the person to basically be able to think more, to step back without doing all the tedious, painful stuff we all have to do all day long, debugging whatever and fighting with,
oil.
I mean, we like to joke that 90% of our job is living in dependency hell. You're just fighting with random things breaking all the time, and then you're debugging stuff you didn't even write. And we would like to try to, as a community, address those types of pains, so then we can step back and really think about okay, so let's imagine that we've automated everything with traditional algorithms and then added this layer of AI on top of it, smart agents that are able to learn and adapt and so on. What's the role of the human in that world? A lot of people think, well, we're going to be obsolete, we're going to be out of jobs, right? And it's like, no. So if you think about from a software engineering cost and from a cybersecurity operations cost perspective, if you reduce the marginal cost of something, you actually make it higher demand. That's the classic Jevons paradox. So in reality, we're probably going to be growing the industry dramatically with all this technology, because now us people, we have a special role in this. AI, as far as I know, nobody's tried to address how to give AI any sort of willpower. It doesn't have any goals. It asks you what you want. So your
Right.
goal in the end is, and unless someone comes up with like the primal brain of AI or whatever, it's essentially just a giant neocortex that's there for us to use. And as a result, we are the willpower. We're the selector. We're the evolutionary selection function for whatever this ecosystem becomes. And so we have this extremely important role because the AI simply doesn't have the ability to do that, unless someone comes up with some wicked ass AI code that really solves that problem. But I don't see anybody working on that one yet.
Yeah, I'm with you there, man. Like, we saw the same sort of transition with the Industrial Revolution, right? And then coming into autonomous factories, but like
Yeah,
there are still thousands of humans working in a nearly fully autonomous factory. So it's okay. But back to malware reversing and sandboxing.
yeah,
I mean, I think many on the call would probably already agree that this is a very useful and necessary thing because one of the areas that I see SOCs losing efficiency it's probably more on the less mature socks that
Yeah.
are getting stuck in this rabbit hole. Is you've got some hobbyist that thinks that every malware sample that presents itself in our environment needs to be reverse engineered, right? We've got to pop it open tonight at Pro or whatever. And I see that as this massive time sink, right? It's like one, it's rare to have the skill set on a team to perform proper reverse engineering. And
Yeah.
two, the return on that is often not going to justify the time it took to do it. So leveraging something that can do this in a fast, automated fashion and provide expert analysis, decision enablement context for an analyst. Like, I
Absolutely.
feel like this is the only way to do it, right? I don't think anybody
Yeah.
should be popping open a sample in a hex editor unless you, one, really know what you're doing, and two, have a really strong justification for why we must understand every last instruction or API call or whatever inside this payload, when most of those answers can probably be gleaned from Sandbox.
Absolutely. I think of everything in terms of, evolutionary game theory and opportunity cost. And you're absolutely right. Like in most cases, you just flat out can't justify that. Even if you might get something interesting out of it, like unless, there's people at the, like, I don't know what you're gonna call it, like tier 3 or tier 4 level that write config extractors and that will if it's a new malware family, they'll sit down with it for months and tear it apart and really get it all figured out. But then they're going to then take that and turn that into a static analysis tool they can run a million times. So there's got to be like a reward for that level of effort. But getting back to like Jevons paradox, if you can say make reversing more automated and reduce the level of effort by a substantial factor, then you do make it more useful, because then people it opens up more use cases where it does justify the effort to put into it. So
Yeah,
that's really where we're trying to kind of make progress on that front.
I think there's a thing, what we've seen happening as far as automation is it's kind of naturally evolving, actually, is that I would say the most advanced like SOC teams or MDR teams, they actually do have a lot of automation, but think about it in terms of holistic. So, the goal is to completely automate security for your network. And so you have all these tools, maybe you buy some, maybe you have your own custom scripts, that kind of stuff. That's all going to feed in as this automation that's constantly watching your network. And so what we actually see happening is that blocks a lot of the stuff. So you don't really need to look at that anymore. But there's this constant trickle of stuff that comes through. You've got the other side of the attackers that know they have all this automation to break through. And so they spend their day trying to figure out how to break through it. And that trickle that gets through your network, and it's actually a little bit different in each network. And we were talking about the ecosystem before. So I think, if you talk about like where are you going to focus your energy, that's where we've seen the most mature teams do, is they'll get all the automation in place that's doing the defense, and then they focus on the samples that are breaking through, and they're like, hey, how is this breaking through all my automated defenses? I'm going to care a lot more. I'm going to dig into that and then feed that back into your automated defenses.
Yeah, Robertson, I like your comment there. It's very similar to frequency analysis. It's looking for the outlier, the lowest frequency, or the most novel or interesting thing that pops out on the other side. The thing that was not able to be triaged by my masterfully planned SOAR playbooks, right? What is this? Why did this make it through? Yeah. That is the goal, right? That is the end goal.
Yeah, and the one
So,
thing oh, go ahead.
no, you go ahead.
Yeah, one thing we've kind of been realizing lately is, and we're actually interested in this personally, is that you've got these different rule sets out there. You've got like the Saracata rules, the Yara rules. There's other types of rules for different types of behavior or whatnot, and that's actually where a lot of action is, I would say, for defenders, because that's where you can say, okay, well, I'm gonna, maybe I don't need to reverse engineer this sample perfectly, but can I use these tools that are actually nice little things that are easy to write a rule in a few hours, plug that back in to get my automation just a little bit better for my ecosystem.
Yeah, but then again, one of the areas I think that the sandboxing approach excels over the quick static analysis is some things simply can't be observed until detonation, right? Because it's packed, if it's obfuscated, like I might want to throw Yara signatures over something all day long, but I might not get the results that I'm looking for statically, right? Just looking
Yeah.
at the file statically. And so that's again an area where execution kind of prevails in the analysis of a
Yeah.
sample. And that really can only happen in a sandbox or on a victim system, whichever you prefer.
Yeah, I think that's where the programmability aspect really becomes important. Like if you're just getting like a raw report out of the sandbox and it's only based on like kind of predetermined samples, that limits what. So the way that I like to think about this is you use dynamic analysis basically as a fancy unpacker, and then you can then use all of your static analysis stuff on the artifacts you extract
Right.
out of the sandbox. And so the programmability aspect of it's really important to be able to say, okay, well, in this situation, this static rule doesn't really apply until this specific situation. To get to the most extreme example, you could have malware that like unpacks itself only briefly, does something, and then clears that section. So you need to be able to see that memory when it's actually active to be able to run your YAR rules against it or whatever. So being able to have like that fine grained control, I think, is really the key to the whole programmable sandbox concept, where you can say, here's a specific set of triggers that I'm interested in, and then here's exactly when I want to run these rules.
So let's use the last few minutes to expand on this concept a little bit more. This was actually the key topic of the day, so
Yeah,
forgive me
yeah.
if I derailed this, but yeah,
It's all good.
what is a programmable sandbox workflow for somebody that's got very little experience with sandboxing?
Yeah.
What is that, and how does it change the game for them?
Well, I guess the nice way of saying this is there's an incentive structure around, trying to basically protect some of the capabilities for vendor lock-in reasons, basically. I think that's historically limited what sort of APIs are available in the sandbox environment. You know, the other thing about it is with us, we have this record and replay, so it really does open up a lot of options that aren't previously possible. So between those two things, we're very much in line with Max's ideology on, everything should be very open and interoperable and things like that. But the idea is that you have this API that's just this super broad API that lets you say, okay, well, so we have this concept of data tokens that we presented at Mission Control, and a data token is essentially, it's a tuple where each part of the tuple is an argument that could be, like, here's the recording ID, here's the process ID, here's a starting and stop time, things like that. So then you can really like zoom in and narrow down to the specific data, and then you end up getting this stream of events that you can process. And those stream of events could be, system calls, they could be API calls, they could be function calls and user space, it could be anything. And so basically use that data token to sort of zoom in on the specific stream of events you want, and then you can feed that, and so you can call and get those events back, and then you can feed that into your own tools to then post process that data. So that's kind of the basic workflow. There is you get the recording of the thing, then you use a data token to zoom in on something, and then you feed that into whatever workflow you want to do with it.
Got it, man. That's pretty slick. Yeah, so definitely recommend anybody that's kind of interested in this concept, check out what these guys are doing. REnigma is definitely kind of changing the game. You guys, you remind me of some of my other favorite products, right? Like folks that are kind of taking a new approach to an old problem, right? Because sandboxing's been a thing for a little bit, but I think a lot of the solutions that exist are kind of hanging on to the older way of doing things. A little bit more limited, to your point, like, very kind of black boxy, don't really know how it's doing what it's doing. I'm only able to configure it to a certain degree. And so love that you guys are kind of taking a refreshed approach to it. Any parting thoughts or words of wisdom? How can folks get hands-on with this stuff?
We started a YouTube channel a couple months ago, and we've been posting videos. So check us out on YouTube. It's just DTRSec is the YouTube channel name. So we'll have a lot of samples there, and then they can reach out to us if they want to, see demos and things like that. We'll also be at B-Sides Charm in April, doing a table to demo things there. So, we're really looking to kind of show this off to people and see who can use it and what's valuable to them.
Outstanding, gents. Really appreciate you guys joining us today. Thanks so much for sharing your wisdom and also for the passion that you pour into REnigma and the other awesome things that you guys are doing. Everybody else, thank you so much for joining us. Be sure to jump into Slack, and we'll see you same time, same place next week. Take care, everybody.